Well, Algebra Geometry 3 classes, again, good morning, good afternoon, or good evening. We're going to go ahead and finish up 10.1 with the second day of notes here and get you all set with that. So, with that 10.1 day 2, we're going to continue with simplifying rational expressions, and probably the biggest thing to remind you from the first set of notes is you can only cancel factors that are multiplied. So like if you have something like 5 plus 7 over 5 minus 1, that does not equal 7 over negative 1. Basically, what this note is wanting to show you is we cannot cancel the 5s. So that's probably the biggest takeaway with that. Like it says right here, you can only cancel factors that are multiplied, which means a lot of the time we are going to have to factor. So you cannot just get rid of these 5s. What you have to do first, out of the 5a plus 10, is divide out or factor the greatest common factor of 5 out of both terms from the top. Divide 5 out of 5a, you get a. Divide 5 out of 10, you get 2. And so then you are able to cancel those 5s and you're left with a plus 2. So we are going to look at simplifying several of these. One of the things too, we are not going to make you go through and list your excluded values. So for the first one, there's actually two different types of factoring that are going to show up here. On the actual paper notes, this just says 4x plus 12. There was another variable there that I did get rid of, didn't notice it until after I had printed. So 4x plus 12, well, we are able to divide a 4 out of both 4x and 12. So when I divide the 4 out of 4x, leaves x. Divide the 4 out of 12, I get 3 now. The x squared minus 9, this is a difference of two squares. I know one of the things that's going to show up when you do this section is a lot of the factoring from first semester. Well, when I take the square root of x squared, I get x. Take the square root of 9, we end up with one factor of x minus 3. The other factor is plus 3. If I were to multiply these back out, negative 3 times positive 3 gives me that negative 9. So now we are able to cancel the x plus 3's, and that leaves 4 over x minus 3. All right, example 2. 4x minus 12 over x squared plus x minus 12. Well, again, for the top, we have a GCF. We can divide a 4 out of both 4x and minus 12. Divide the 4 out of 4x, it leaves x. Divide 4 out of minus 12, it's minus 3. So the numerators in both of these examples are almost the exact same. Now, when I have a trinomial, this goes back to something we talked about on 10.1 day 1. I have to find what multiplies to negative 12 adds to positive 1. Well, in terms of what multiplies to 12, 1 and 12, 3 and 4, or 2 and 6 do that. Now, in order to add to a positive 1, that means our smaller number in the factors will have to be negative. So what multiplies to negative 12 adds to positive 1, negative 3, and 4. So that means my two factors here are x minus 3 and x plus 4. So now as far as what cancels, the x minus 3's do. So I am left with 4 over x plus 4. Now, again, probably the single biggest issue that shows up on question 2. Do not cancel these 4's. Again, the only way you can cancel is if I have an entire quantity, because the x plus 4 essentially goes together. This is your final answer there. All right, on example 3, a squared plus 5a over a squared plus 10a plus 25. Again, do not try and work with individual terms when there is addition. We are going to have to factor first. Now, our numerator, again, anytime you have two terms, usually you're looking for a GCF. A squared and 5a, I can actually divide an a out of each of those. If I divide an a out of a squared, it leaves a. If I divide a out of 5a, it leaves 5. Now, the denominator, again, I have a trinomial. I'm looking for what multiplies to 25, adds to 10. Well, in terms of what multiplies to 25, our options are either 1 and 25 or 5 and 5. Well, of those, what multiplies to 25 and adds to 10? 5 and 5. So our factors here are a plus 5 and a plus 5. Now, when I have two a plus 5s in the denominator, 1 in the numerator, I can only get rid of 1 from the denominator. So that's going to leave us with a over a plus 5. Now, much like up here, we could not cancel the 4's because I need an entire x plus 4. Here I cannot cancel the a's. The a plus 5 is a quantity. I cannot reduce those a's. So that is my final answer there. All right, last few examples here that we're going to now look at. On example 4, we are going to have 2 sets of factoring for that. And with it, for the numerator, I need what multiplies to -5 and adds to 4. For my denominator, what multiplies to 20 adds to 9. Well, as far as the numerator goes, what multiplies to -5? Only worry about the 5 for the time being. Well, the only things that multiply to 5 are 1 and 5. Now, in order to get the signs correct, if it adds to a positive, that means the smaller number of my factors has to be the negative. So our numerator will factor into b minus 1 and b plus 5. For our denominator, what multiplies to 20? Well, 1 and 20, 4 and 5, and 2 and 10. Well, of those, what multiplies to 20 and adds to 9? 4 and 5 is our option there. And so for this, b plus 4, b plus 5. So the b plus 5s are what cancel, leaving us with b minus 1 over b plus 4. All right, for our next example, before I do anything with this, I am going to actually rewrite this in order. I'm going to rewrite it as -3x plus 12 and x squared minus x minus 12. Now, as far as our GCF goes here, one of the reasons why I like to rewrite this, it makes the GCF a little more obvious when you have this coefficient first. Out of -3x and positive 12, we always want to try to turn this variable term into a positive. So that means I can actually divide not just a 3, but a -3 out of both of these. So when I do that, my -3, the GCF, comes out to the front, leaving x. Divide 12 by -3, that leaves minus 4. Now, as far as factoring x squared minus x minus 12 goes, what multiplies to -12 adds to -1. Well, what multiplies to 12? 1 and 12, 3 and 4, or 2 and 6. Now, if it adds to a negative, that means the bigger number has to be negative. So the combination that gives us -1, 3, and -4. So our factors are x minus 3 and x minus 4. So as far as what cancels, the x minus 4s. And that leaves -3 over x minus 3. Now again, with all of these questions, when you work with rational expressions, it's very common that you see answers where you have something very similar. Again, I've got a -3 on the top, x minus 3 on the bottom. Do not cancel those. That is something that we cannot do. All right, example 6, a little bit more of a challenging question here. A to the third minus 11a squared plus 30a over 2a squared minus 18a plus 36. This is one that actually has a GCF for both before we can do anything. If you have a to the third, that's not something you're going to want to factor initially. I can divide an a out of every term in the top, leaving a squared minus 11a plus 30. For my denominator, I can actually divide a 2 out of everything. -18 divided by 2 is -9. 36 divided by 2 is 18. Now, we are going to be able to factor this. So, I'm going to work with just the parenthesis. For the top, what multiplies to 30 and adds to -11. It's actually going to have a combination we haven't seen yet. 1 and 30. 5 and 6, 3 and 10, or 2 and 15. If it multiplies to a positive and adds to a negative, that means both numbers have to be negative. Now, certainly as you work these through, you usually find those patterns. Now, as far as what's going to multiply to 30 and add to -11, -5 and -6. So that means my numerator, which I'm going to work down the page here because I am starting to run out of space, off to the side, a minus 5 and a minus 6. Now, for the denominator factoring, what multiplies to 18 and adds to -9. Well, as far as what multiplies to 18, 1 and 18, 2 and 9, 3 and 6. Now, much like over with what we did for the numerator, if it multiplies to a positive and adds to a negative, all of your values have to be negative. Here, multiplies to a positive, adds to a negative. All of our values are going to be negative. Now, what multiplies to 18 adds to -9 is -3 and -6. So, I am going to bring down our GCF, and then our factors are a minus 3 and a minus 6. The a minus 6's cancel, leaving us with a times a minus 5 over 2 times a minus 3. So, again, the a's do not cancel. Your end result is a times a minus 5 over 2 times a minus 3. So that finishes up the second half of the 10.1 notes. There are 2 different assignments you can actually work on now from 10.1 on Schoology.